Hey everybody, it's Morgan here. So we're going to be looking at some pages in our lecture outline, pages 13 and 14, 15, talking about excess and limiting reactants. And we introduced that on the previous page, and we did that nice little homework of the particulate diagrams that talked about how that worked. So now I want to look at it from a mathematical point of view. So we're going to react 10 grams of H2 and 10 grams of O2. And the reaction equation is 2H2 plus O2 to give us 2H2O. Now, how many grams of water are produced when this happens? Well, I don't know which is the excess and which is the limiting reactant. So I need to do calculations for both. 10.00 grams of H2. Now, 1 mole of H2 weighs 2.02 grams of H2. According to this equation, 2 moles of H2 give me 2 moles of water, and 1 mole of water has a molar mass of 18.02 grams of water. So these cancel, those cancel. Now this comes out to be 89.21 grams of water. And I'm pretty sure right away that that's not going to be the limiting reactant. That answer really doesn't make sense. 10 grams and 10 grams together is not going to turn into that much. So let's try the other one. 10.00 grams of O2 times 1 mole of O2 is 32.00 grams of O2. 1 mole of O2 from the balanced chemical equation gives me 2 moles of water, and 1 mole of water has a molar mass of 18.02 grams of water. So grams of O2 cancel, moles of O2, moles of H2O. Now, when I ran that through my calculator, I got 11.26 grams water. Now, that's a smaller number than this. That means that oxygen is my limiting reactant because it makes less product, and hydrogen is my excess reactant because it makes more product. So this is how much water can actually be made. So who's the limiting reactant? O2. Because it makes less product. Now, how much of the excess reactant is left over? Well, there are a few different ways to do this. Now, kind of a shortcut that works in this problem but will not work in other problems is that I can say 10 grams of hydrogen and 10 grams of oxygen, that's 20 grams. If I have 11.26 grams of water, 20 minus 11.26 tells me that I'm going to have about 8.74 grams of hydrogen left over. Now, that's not how we typically do it, but that is kind of a common sense thing for us. So how much of the excess reactant is left over? What I'm going to do is I'm going to take my 89.21 grams of water minus my 11.26 grams of water. And that gives me 77.95 grams water that I did not make. I had enough hydrogen to make it, but I didn't have enough oxygen. So now I'll do the same thing I already know how to do and work backwards. See, I like doing this because it's a method I already know. So why not use a skill I already have? So then I can say 2 moles of water. And my leftover is hydrogen, so 2 moles of hydrogen. 1 mole of H2 is 2.02 grams of H2. Now this cancels, that cancels. When I run that through my calculator, I get 8.74 grams of hydrogen. Now that sounds familiar. Oh yeah, huh? Isn't that the same number I got right there? Okay? So my common sense answer, my mathematical answer, they're lining up. Now this only works as a technique, this taking the difference here, when I have one product. If I had two products, I couldn't do that. All right, so now sodium's going to react with oxygen. Na plus O2 to give me Na2O. I have to put a 2 there and a 4 there. So same numbers. I got 10 grams of sodium, 10 grams of oxygen. How many grams of Na2O are produced? So what I can do is I can say I have 10.00 grams of Na times, okay? Now, then I'll say 1 mole of sodium weighs 22.99 grams of sodium. 4 moles of sodium gives me 2 moles of Na2O, and 1 mole of Na2O is 61.98 grams Na2O. I added these up before we started. Okay? Those will cancel, those will cancel, those will cancel, and this is 13.48 grams. Could be the answer, maybe not. We have to check the other one. It's reasonable. 10.00 grams of O2 times 1 mole of O2 is 32.00 grams of O2. 1 mole of O2 gives me 2 moles Na2O. 1 mole Na2O is 61.98 grams Na2O. I'm not doing those in my head, folks. I added them up. You can see. I worked it out earlier. So, these cancel. These cancel. These cancel. And that equals 38.74 grams Na2O. Well, I can't make that much. I mean, 10 grams and 10 grams is not going to make almost 40. This is the smaller number. The smaller number comes from the limiting reactant. So the limiting reactant is sodium. Okay? Now, I could just say, all right, 10 plus 10 is 20. Let me show you how that works here. 10 plus 10 equals, I got 20 grams minus, I made 13.48. That equals 6.52. Okay? So I could say, 6.52 grams left over. Okay? What's left over? Who's the excess reactant? Oxygen. Or the proper way to do this is to say, all right, 38.74 grams of Na2O minus the 13.48 grams Na2O. That comes out to be 25.26 grams Na2O. Convert this back into the excess reactant, which is oxygen. 1 mole Na2O is 61.98 grams Na2O. 2 moles Na2O. Give me 1 mole of O2. And 1 mole of O2 is 32.00 grams of O2. That cancels. That cancels. That cancels. And this equals 6.521 grams of O2, which is basically what I got here. The difference in these answers is only due to the rules of sig figs. 6.52, okay, as opposed to 6.521. Let's not worry about that. They'd both get full credit. Okay, so top half of the page there, the first question. Put there for you for a second. Bottom half of the page. Leave that there for you for a second. All right, now let's go on to the next page. Let's talk about page number 14 now. All right, so these are some examples to introduce a concept called percent yield. Okay? So, we've been doing a lot of baking as the holidays are coming up soon. Thinking about making cookies. So, the recipe tells me that I'm supposed to get 2 dozen or 24 cookies, but I only get 12. What percentage did I get? Well, 12 out of 24 times 100% equals what we'll call a 50% yield. Now, that's probably because I made the cookies bigger than the recipe called for, or maybe it's because I kept munching away on some of the raw cookie dough. I gave some to the dog, things along those lines. All right? But in chemistry, sometimes reactions are not as efficient as they should be. And even though we have enough materials, it doesn't make as much product as we're supposed to. So I have the theoretical yield and the actual yield. The theoretical yield is what I should get. And the actual yield is what I did get. So up here in the cookie example, the theoretical yield was 24, but the actual yield was 12. So my formula to figure out a percent yield is to take the actual yield, divide by the theoretical yield, multiply that by 100%, and that equals my percent yield. And we do that a lot, okay? A lot of questions like that inside of a laboratory situation. So, what affects the percent yield of a reaction? Well, spillage. If I don't get all of my reactants into the beaker, okay, I can lose some there, all right? Not letting it react long enough can affect it, okay? I actually left some of the product in the beaker, didn't get onto the balance, okay? Lost product, lost reactant. Lots of different things can happen. We do a lot of neat labs about this when we get back in the classroom. Now, can I have something greater than 100% yield? The answer is yes, but it's not actually yield. It's probably leftover starting material. Okay, so let's try a question here. Fred and Wilma mix 12.5 grams of copper with excess chlorine. That's going to be Cu plus Cl2 gives me CuCl2. Okay, they produce 25.4 grams of copper 2 chloride. What's their percent yield? Well, let's find the theoretical. 12.5 grams of Cu times. Now, 1 mole of copper is 63.55 grams. 1 mole of copper in this equation gives me 1 mole of CuCl2. 1 mole CuCl2. 134.45 grams is the molar mass as I added it up. So those cancel, those cancel, those cancel. And this equals 26.4 grams of CuCl2. Now I'll call that my theoretical yield. That's how much the math says I should get. Now the actual yield is what I did get, produces 25.4. So 25.4 grams divided by the 26.4 grams times 100% equals 96.2% yield. Okay? So why don't you take a second, pause the video, try question number 2, then tune back in. Okay, let's see how you did. So mercury oxide decomposes. 2HgO gives us 2Hg plus O2. Okay? I have 500 grams HgO. Let's see how much oxygen that should make. 1 mole of HGO is 216.59 grams HGO. Then 2 moles HGO gives me 1 mole of O2. And 1 mole of O2 is 32.00 grams of O2. That's going to cancel, that's going to cancel, that's going to cancel. This equals 36.9 grams O2. So that's my theoretical yield. That's what I should have gotten. What I did get, according to this question, was 35.0 grams of O2 divided by 36.9 grams, theoretically, times 100%. And this equals 94.8%. Okay, there you go. All right, so now we're going to attack homework, which is called Roadmap Problems number 2, Limiting and Excess Reactants. I hope you all have a good time with that. Okay, this is Morgan, signing off.